So our first example is x divided by 2 is less than 2.5, right? So the objective is to get x by itself, which is the variable in this case. And then you observe and you look at what is happening to this x. This x is being divided by 2. So in order to transfer this 2 over to this side, we're going to do the opposite operation, right? So step 1, we're going to multiply both sides by 2. How would you state this in your book? This is how you would state it. So you would have 2, a bracket, x over 2, close bracket, less than 2, and you put a bracket and you put 2.5 in there. Now, the bracket means multiplication, so you don't need a multiplication sign. It means that you are multiplying. That's what it implies. So clearly here, you can see that when you simplify, this 2 in the numerator is going to cancel out this 2 in the denominator, which leaves you back with x. So step 2, you're going to simplify. And when you simplify, what do you get? You're going to get x is less than 5, because you can see that 2.5 is just 2.5, right? And 2 times 2.5 would just give you 5. And that's your solution there. And hence the solution set is the set of all x's such that x is less than 5. And it's always good to practice to represent your solution on a number line. So I'm just going to represent the solution on a number line very quickly for you. So the first thing, when we look at the sign, we notice there is no line underneath it. It means that we're going to use an open circle. So we're going to locate 5 on our number line, and this is 5. So we're going to put an open circle above 5 there. Then the next thing that we need to decide is where we're going to put the arrow, whether to the left or to the right. Then you just reread your solution. X is less than 5. So what are some values that is on this number line that are less than 5? We have 4, 3, 2, 1, 0. And you notice I'm moving towards the left. That means the arrow should draw towards the left like this, right? And that's how you would represent your solution on a number line. Let's look at the second example. So the second example we have is x over 3 is greater than 1/6. Now, again, the principle does not change. We want x by itself, which is the variable. We look at what is affecting x. X here is being divided by 3, which means that we want to transfer this 3 to the other side. So in order to do that, we must do the opposite operation. So step 1, we're going to multiply both sides by 3, right? And then how would you state that in a book? You're just going to write 3, open bracket, x over 3 greater than 3, open bracket, 1/6. Remember that the bracket implies multiplication, so you don't need a multiplication sign. At that stage, you're just going to simplify. And when you simplify, your solution would be x is greater than 1/2. And hence, your solution set is going to be the set of all x's such that x is greater than 1/2. And then we can also represent our solution on a number line. So let me represent my solution on my number line quickly for you. Again, we take a quick observation of the sign. There's no line underneath it. It means that we're going to use a open circle, right? But here I only have whole numbers. So first I need to identify where 1/2 would be. So half would be halfway between 0 and 1. So let me put a stroke that represents a half. So half would be just about here, right? So that's where half is. So we need to place an open circle above that line that represents half. So it would be somewhere around here. Then we need to decide on the direction. So it says that x is greater than a half. So what is one value that is greater than a half? 1, another value 2, 3, 4, and so on. Notice I'm going towards the right. That means that the arrow should draw towards the right. And that is it. That is how you would represent x is greater than a half and a number line, right? So our third example is negative x all over 2 is less than 2.5. Does the principal change despite a negative is here? Absolutely no. The objective is we want x by itself. So what we're going to do is step 1, because this negative x is being divided by 2. How can we transfer it? To the opposite of divided by 2, which is to multiply by 2. But we must ensure that we multiply both sides by 2. So step 1, multiply both sides by 2. And this is how you would write that. So you note again, just put whatever you have in the question in a bracket and put 2 on the outside. Then step 2, you're going to simplify. So when you simplify, what you will end up with is minus x is less than 5, because clearly you can see that 2 into 2 will give you 1, and minus x over 1 is just minus x. And 2 times 2.5 is just 5. Are you finished here? Absolutely no. You have an additional step, which is step 3. So you're going to multiply both sides by negative 1. Why? Your variable cannot be negative. Your variable should always be positive. So if we multiply both sides by negative 1, how would we write that? This is exactly how you would write it. So you would end up with negative 1 times minus x is less than negative 1 times 5. But there is a very important concept that you need to remember. Whenever you multiply by a negative number or you divide by a negative number, it means that you should switch the side or flip it. So if the sign was less than, it is going to become greater than. If the sign was greater than, it is going to become less than. If the sign was greater than or equal to, the sign is going to become less than or equal to, right? So in this case, after multiplying by negative 1, our solution would be x is greater than negative 5. So as you can notice here, my sign is being switched. Very important. And then you can still represent your answer as a solution set, which is the set of all x's such that x is greater than negative 5. All right?
Yes, sir.
So just always remember that multiplying by a negative means switch the sign. So we're going to move to example 3, which is just x over 3 is greater than or equal to 1 over 6. Again, we want x by itself. This x is being affected by 3 because 3 is dividing this x. So how can we transfer this 3? By multiplying both sides by 3. So step 1, multiply both sides by 3. And that is how you would state it in your notebook, right? Then after this, what are you going to do? You're just going to simplify. So when you simplify, what should you get? You're going to get x is greater than or equal to a half. And then what would be your solution set? You write it using set builder notation, and it's simple. This solution set is read as the set of all x's such that x is greater than or equal to a half. All right. And we can always represent our solution on a number line, right? So let me represent my solution on a number line since it is a fraction. So the first thing when we observe our symbol here, notice there's a line underneath the sign. That means we should use a closed circle because this is saying that a half is a part of the solution. So we know that a half will fall halfway between 0 and 1. So a half would be somewhere around here. So we'll put a bold circle like that. And then what we need is an arrow to show the direction, and then we are finished. So it says x is greater than or equal to a half. So greater than a half would be 1, 2, 3, and so on. So our arrow would be drawn in this direction. And that's it. So that's it for this case. So whenever you have a problem and you encounter division in there, remember, you do the opposite. So if you have a division and you want to transfer it to the other side, then you multiply both sides by whatever number you were originally dividing by.